Hi, Assalamualaikum and good day. Today you are going to learn on how to do analysis on functions. Following are the objective of today's lesson. Hopefully, by the end of this session, you should be able to 1. Identify the interval where the function is increase or decrease. 2. Determine the extremum points that are either maximum, minimum, or inflection points. 3. Identify the interval where the function is concave upward or concave downward. And finally, sketch the graph. Let f be differentiable on the open interval AB. If f prime is less than 0 or equal to negative value, the function f is decreased on the given interval. If f prime is greater than 0 or positive value, the function f is increased on the given interval. And if f prime is equal to 0, the function f is said to be constant. Take note that if the function is increased, the graph is moving upward. If the function is decreased, the graph is moving downward. And if the function is constant, the graph is static. Following are the steps in finding the increasing or decreasing interval. First, determine the f prime x. Next, find the value of x equal to c when f prime x equal to 0. Then, substitute x equal to c into the fx to obtain the critical points. Identify the intervals by taking x equal to c as the cutting point. And finally, determine the sign of f prime x in each interval. If the sign is negative, the function is decreased. If the sign is positive, the function is increased. Refer to example 1. You need to find the increasing or decreasing intervals for the given function. To solve, you need to find the answer for f prime x first. Differentiate fx equal to x squared plus 1. The answer is 2x. By letting f prime x equal to 0, you should get x equal to 0. Substitute x equal to 0 into the fx, you should get y equal to 1. Therefore, the critical points for the given function is given by 0, 1. By taking x equal to 0 as the cutting point, you should get two intervals, negative infinity to 0 and 0 to infinity. Next, you need to determine the sign of f prime x. By taking any value within the interval, you will get negative sign from 0 to the left and positive sign from 0 to the right. Therefore, the function is decreased on the interval negative infinity to 0 and increase on the interval 0 to infinity. If you refer to the graph of x squared plus 1, from negative infinity to 0, the graph is going down, and from 0 to infinity, the graph is going up. Let's proceed with example 2. You need to find the interval where the given function is increased or decreased. Differentiate 3x to the power of 2 over 3, you should get 2x to the power of negative 1 over 3. By letting f prime x equal to 0, you should get x equal to 0. Substituting x equal to 0 into the fx, you should get y equal to 0. Therefore, the critical points for the given function is 0, 0. By taking x equal to 0 as the cutting point, you will obtain two intervals, negative infinity 0 and 0 infinity. Next, check the sign of f prime x. By taking any value within the interval, you will get negative sign from 0 to the left and positive sign from 0 to the right. Therefore, the function is decreased on the interval negative infinity to 0 and increase on the interval 0 to infinity. When you refer to the graph of the given function, you will notice that the graph is going down from negative infinity to 0 and going up from 0 to infinity. Refer to example 3. You need to find the critical points and determine the interval where the function is increased or decreased. Differentiate the given function, you should get f prime x equal to 3x squared minus 12x plus 9. By letting f prime x equal to 0, using factorization, you should obtain x equal to 1 and x equal to 3. Substituting these x values into the fx, you will obtain two critical points, which are 1, negative 6 and 3, negative 10. By taking the x values 1, 3 as the cutting point, you will obtain three intervals, which are negative infinity to 1, 1 to 3, and 3 to infinity. Now, let's check the sign of f prime x for each interval. By taking any value within the interval, you should obtain positive sign from negative infinity to 1, negative sign from 1 to 3, and positive sign from 3 to infinity. Therefore, the function is increased on the interval negative infinity to 1 and 3 to infinity, and decreased on the interval 1 to 3. Next, we are going to learn on how to find the extremum points for the given function. Extremum point is referred to the critical point, which is either maximum, minimum, or inflection points. Following are the steps to determine the extremum points. First, you need to find the critical point using the first derivative test. Then, using the increasing and decreasing interval that you have learned earlier, you can determine the extremum points. You can also use the second derivative test to find the extremum point. By using the second derivative test, you need to differentiate the f double prime x first. Next, substitute the x values of the critical points into the f double prime x. If the f double prime is less than 0 or negative, then the function has a maximum point. If f double prime is greater than 0 or positive, then the function has a minimum point. If f double prime equal to 0, then the function has an inflection point. Refer to example 4. You need to find the extremum point for the given function. For this function, we have identified the interval where the function is increased or decreased. Under the first example just now, we conclude that the function is decreased on the interval negative infinity to 0 and increased on the interval 0 to infinity. Therefore, the critical point 0, 1 is said to be minimum. Alternatively, you can also use second derivative test to identify the extremum point. After you obtain the critical point 0, 1, next is you differentiate the f prime x. You should get 2 as the answer for f double prime x. As the value of f double prime x is greater than 0, we can conclude that the critical point 0, 1 is the minimum point. Let's proceed with example 5. You need to find the extremum point for the given function using the second derivative test. To solve, you need to differentiate the given function first. Differentiate the fx, you should get f prime x equal to 3x squared minus 6x minus 24. By letting f prime x equal to 0, you will obtain x equal to negative 2 and x equal to 4. Substituting the x values into the function, you should get two critical points, which are negative 260 and 4 negative 48. Next, determine f double prime x. By differentiate f prime x that you have obtained just now, you should get f double prime x equal to 6x minus 6. Then, substitute the x value into the f double prime, you should get f double prime negative 2 equal to negative 18, which is less than 0. And f double prime 4 equal to 18, which is greater than 0. Based on the f double prime values, we can conclude that negative 260 is the maximum point and 4 negative 48 is the minimum point. Refer to example 6. You need to determine the extremum points for the given function. To solve, you need to differentiate the function with respect to x first. You should get f prime x equal to 6x squared plus 2x minus 4. By letting f prime equal to 0, you should obtain two x values, which are 2 over 3 and negative 1. By substituting this value of x into the given function, you will get two critical points, which are 2 over 3, 16 over 27 and negative 1, 8. Next, determine f double prime x. By differentiate the f prime x with respect to x, you should get 12x plus 2. Substitute the x values into the answer, you will get f double prime negative 1 equal to negative 10, which is less than 0, and f double prime 2 over 3 equal to 10, which is greater than 0. Based on these values, we can conclude that negative 1, 8 is the maximum point and 2 over 3, 16 over 27 is the minimum point. Next,